Hey guys, and welcome to Clean Campus Chemistry Series. Presenting episode 3, topic Principle of Chemistry Part 3. The things we should cover in this episode: heating and cooling curves, elements and compounds, physical and chemical properties. So we're at heating and cooling curves. So if you look at this, you would see that this substance is going through the changes in temperature, and as you can see, it's moving from different states. So we're going to read each information, and at each point of this graph is labeled. So from AB, so increasing heat energy increases the vibrations of the particles in solid. So the temperature of the solid increases. So from B to C, so the forces of attraction between the particles are weakened enough so that the particles slide over each other. The temperature is constant because the energy is going to overcome the forces between the particles instead of raising the temperature. The substance melts. Now from C to D. So increasing the energy increases the movement of particles in the liquid, so the temperature of the liquid increases. So we are at from B to E. So the forces of attraction between the particles are weakened enough so that the particles move well away from each other. The temperature is constant because the energy is going in to overcome the forces between the particles instead of raising the temperature. The substance boils. From E to F. Increasing the energy increases the speed of gas particles, so the temperature increases. And this here shows the temperature of a solid changes when it's heated slowly to form a liquid and then a gas. So we're going to discuss sublimation. So sublimation is the direct change of a solid to a gas on heating without any liquid state being formed. It also refers to the direct change of a gas to a solid on cooling without the liquid state being formed. And you can see that when we apply heat to a solid, it changes directly to gas, and vice versa. We reduce the temperature from the gas, and it reverts back to a solid. So an example is solid carbon dioxide, which changes directly to carbon dioxide gas when heated. So we're at elements. So an element is a substance made up of only one type of atom. Elements cannot be broken down into anything simpler by chemical reactions. Some examples of elements are shown below. The structures look different, but each of them only has one type of atom. Chlorine has only chlorine atoms, and so on. So example, chlorine, phosphorus, and carbon. And you can see the bond between the atoms, and there's only one type of atom in these elements. So discussing chemical bonds. So in the pictures before, the atoms of chlorine, phosphorus, and carbon are joined by chemical bonds. So a chemical bond is shown by a line joining atoms. A chemical bond shows that there are strong forces holding atoms together. The bonds here are covalent bonds. We will learn about this later. So example, the bond between oxygen molecule. So two oxygen atoms come together and share electrons here, and that's how the bonds are formed. So discussing compound now. So a compound is a substance made up of two or more different atoms, ions in bracket, joined together by bonds. Compounds always have a fixed amount of each element in them. For example, a water molecule always have two hydrogen atoms and one oxygen atom. In sodium chloride salt, the ratio of sodium ions to chloride ions is always 1:1. And you can see is a picture of the atom of a water, an atom of salt or sodium chloride. So there are two main groups of compounds: molecular, giant molecular, where the atoms are bonded together, and ionic, where positive and negative ions form ionic bonds. So we're discussing physical and chemical properties. So physical properties are one that do not generally depend on the amount of substance present. Examples are melting and boiling points, density, mass of substance divided by volume of substance, strength, hardness, electrical and thermal conductivity. Chemical properties, however, describe how elements and compounds react with other substances. For example, sodium reacts with chlorine to form sodium chloride. Sodium reacts with water to form sodium hydroxide and hydrogen. Reacting with elements. So compounds often having different properties from the elements that they are made from. So we can see this by comparing the properties of sodium chloride and sodium chloride. Sodium chloride is the compound formed by the chemical reaction when sodium burns into chlorine gas. So here at the table here we see that the state for sodium is solid, state for chlorine gas, and state for sodium chloride the compound is solid. The color for sodium is silvery, for chlorine green, and for sodium chloride white. So the boiling point in Celsius for sodium is 883, for chlorine -35, and for sodium chloride 801. So the density at room temperature is 0.97 for sodium and 0.00296 for chlorine, 2.17 for sodium chloride. And this is the comparison of the physical properties of sodium, chlorine, and sodium chloride. So at this table now, so the reaction with oxygen, so sodium reacts with oxygen and burns to form a white powder, and chlorine does not react with oxygen, and sodium chloride doesn't react with oxygen as well. So the reaction with water now, sodium react to form an alkaline solution and chlorine react to form an acidic solution, while sodium chloride does not react, just dissolve. And this is a comparison between the chemical properties of sodium, chlorine, and sodium chloride. And this example gives a solid proof of how the elements of its compound form has different properties, and this was a demonstrated example of this. So guys, this is the end of the video. Please like the video if you really enjoyed it, and share it to your friends who really need this video, and don't forget to click that subscribe button for more videos like this. Bye.